Hi, we're going to be working on your homework. It's on page 3 in your interactive notebook. Today we learned about the real number system. We learned all the definitions and categories of the real number system. We learned that all numbers that we deal with are real, so that's why they're included in this large box. And then there are separate categories and categories that are related to each other that help us organize our numbers. So let's start over here with the larger circle. We're going to go into the very specific circle here, which is natural. Remember, natural is the smallest category, and those are the numbers that you count. That's what you learned in preschool and kindergarten, 1, 2, 3, 4, 5, etc. Then, because natural is a subset or inside wholes, naturals can also go out to be wholes. And wholes are 0 plus all the natural numbers. So it's a larger category. Then we're going to get a little bit larger and head on out to integers. And integers are all of your counting numbers. They're 0. And then they're also all of your wholes opposites, like -2 and -3, -4, etc. So that's why that category is getting larger, because it includes all 3 types of numbers. Then the largest category on this side includes all your naturals, your wholes, and your integers, but it also includes fractions and certain kinds of decimals. So those decimals are repeating decimals, like 1.2 repeating or 0.333 repeating. And they also include terminating decimals. And terminating means that the decimal stops after a certain number. So 3.75 is a terminating decimal because it stops after the 5. My example here, -1.7 is a terminating decimal because it stops after the 7. Then if you take a look over here at the totally separate category, these irrationals are all by themselves. They're not related to these rationals, integer, wholes, and naturals in any way other than they're real. And so irrational numbers, remember, a good example is like pi. It's a long decimal that never ends, so it's non-terminating, goes on forever. And then it also doesn't repeat. A lot of your decimals are going to look all mixed up. They're different numbers. There may be a pattern like this one that we did in number 1, 0.43443344. That's a pattern, but nothing is repeating. Repeating means the same number over and over and over again in the same order. So what we're going to do then is we're going to look down at the evens here, and we're going to decide where did these numbers go. And we can look at the odds to help us. So I'm noticing right away that the number 0.121221222, it's got a cool pattern. And I see that it's a decimal, so I have a choice between being rational or irrational. And so to me, it's looking like the decimal continues on forever, and it's not repeating. In other words, the same number is not repeating over and over again in the same order. So that's going to be real and irrational. Sometimes, like in number 4, you've got to find out the value. So I've got the negative square root of 196. If you're at home and you've got your phone for your calculator, take your phone and turn it sideways. That'll give you the square root button. So all you got to do is type in 196, hit the square root button, and it'll give you 14. You notice there's a negative on the outside of the radical, in other words, the square root symbol. So we leave that negative on the outside of our value. So the value of the negative square root of 196 is negative 14. So I'm going to go up here and I'm going to decide where should I put negative 14. Well, it looks like it's very similar to negative 15. And if I am an integer in the integer circle, remember I can only get out, I can only escape. So if I'm an integer, then I'm also rational and I'm also real, just like number 3. The next one, I also have to do a little math. I have 4 to the second power, and 4 to the second power is 16, 4 times 4. And so now I got to decide, where would I put a 16? Well, I know that I can count to 16. 1, 2, 3, 4, 5, 6, etc. So if I can count to it, then that means it is a natural number because it's counting. So I'm going to put 4 to the second right there. And it looks very similar to 2 to the third. 2 to the third is equal to 8. I can count to 8. So that means I am natural, but I'm also inside whole. I'm also inside integer, I'm also inside rational, and I'm real. And then I've got 9 halves, or 9 to the 9 over 2. 9 over 2. A lot of times for the fractions, you can automatically put them in rational if you like. However, sometimes it's good to find the value of that fraction through division. So I like to divide. 9 divided by 2 gives me 4 and 5/10, or 4.5. And that tells me right away that it is certainly rational because that is a terminating decimal. It stops after the 5. So I would put 9 halves in the rational category. So it's real and it's rational. And then the last number, I have negative 5.6. Now, here's a dilemma that a lot of students get into. They see that it's negative and automatically want to put it in the integer category. But remember from our notes that integers are whole numbers. They're opposites and zero. So if you take a look at all of our examples on our notes on page 2, there are absolutely no decimals in the integer category. Integers cannot be decimals. So I know that it stops after the 6, which means it's a terminating decimal, so it's got to be out here in rational. So it's real and it's rational, but it is not an integer, because it is a decimal. Decimals are not integers.